Hi, welcome to Cracking MBA. Today we are going to talk about LCM concept in numbers. LCM stands for least common multiple, and we will discuss about some of the basics of LCM and also look at how to solve questions in remainders using the concepts of LCM. So LCM is a concept which you might have learned in high school as well, right? So we will not go into too much of depth as to how to calculate LCM because a lot of you might already know it. But we'll just touch it for your reference and we look at how LCM can be used to solve some complex questions in remainders related to numbers. Okay. So let's look at an example of how to calculate of what is LCM. So LCM of 4, 7 and 10 is 110. What does it mean? It means that 110 is the smallest common multiple of 4, 7 and 10 such that there is no remainder on dividing by 4, 7 and 10. So the basic definition of LCM is that it is the least common multiple of all the divisors such that after dividing that multiple by all the divisors there is no remainder. Okay. So in this case 110 is the LCM of 4, 7 and 10 because if I divide 110 by 4, 7 or 10 there is no remainder. Okay. Now let us see how to calculate the LCM. There are two prominent methods. One is by identifying the factors and other is by the long division method, which you might have seen in high school as well. So by identifying the factors, what we need to do is, if we need to calculate the LCM of 36, 42 and 64, we identify all the factors. Okay, so the factors of 36 are nothing but 3 square into 2 square, and 42 can be written as 2 into 3 into 7, and 64 can be written as 2 power 6. So identify all the powers of the each number in terms of the prime numbers. Okay, so 3, 2 and 7 are prime numbers and we are writing in terms of the powers of the prime numbers. Next, what you need to do is find the highest power of each prime number and start multiplying them. So in this case, the highest power of 2 is 2 power 6, the highest power of 3 is 3 power 2, and the highest power of 7 is 7 power 1. So we just multiply all of them, okay, 2 power 6 into 3 power 2 into 7, and we get the LCM as 4032. Now what is the logic for behind doing this multiplication of the highest powers? The logic is that if the highest power is there in 4032, then any lower power also will be there. Okay. So if I'm considering 42, right, any multiple of 42 will be there in 4032 because 2 is there, 3 is there because 3 square is already there, and 7 is there because 7 power 1 is already there. So by ensuring that we are giving the highest power for each number, we are ensuring that that particular factor is already present. So we are ensuring that 3 square and 2 square both are in 4032. 2 into 3 into 7 is already there in 4032 and 2 power 6 is also there in 4032. Okay. Let us take another example just for your understanding. So using the factorization method, what is the LCM of 42, 48 and 51? So 42 is nothing but 2 power 1 into 3 power 1 into 7 power 1, and 48 is 3 power 1 into 2 power 4, and 51 is nothing but 3 power 1 into 17 power 1. Now identifying the highest power, we see the highest power of 2 is 2 power 4, highest power of 3 is 3 power 1, and highest power of 7 is 7 power 1, and highest power of 17 is 17 power 1. So if you multiply all of them, we will get the LCM as 714. Okay. Now let us look at the long division method for calculating. So till now we looked at the factorization method. Now let's look at the long division method. So in the long division method, what we do is we take each prime number from the smallest to the largest and keep dividing until there are no further common factors left. Okay. So here we can clearly see of the LCM of 18, 42 and 30. Clearly there is 2 in all of them. So I divide by 2 for all of them. So I get 9, 21 and 15. Next again I see 3 as a common factor between 9, 21 and 15. So I divide by 3 again and I get 3, 7 and 5. Now is there any other common factor between 3, 7 and 5? No. So there is no other common factor between 3, 7 and 5. So I just stop the division further here and I just start multiplying all of them. So I get 2 into 3 into 3 into 7 into 5, which I write down over here, and that is what I get as the LCM. Okay. Now let us look at, so this is a long division method which I think you might have already learned in your high school, so we will not go into too much of depth of this. Okay, so just remember there are two ways of calculating LCM. One is identifying the factors and taking the highest power of each factor, and the other one is the long division method. Okay, so so in the first method of identifying the factors, you need to make sure that the prime numbers are expressed in the highest powers in the LCM, and long division method you already learned in high school as follows, as what is listed in this slide. Now let us see how we can apply this LCM concept. Okay, so two main applications. You might have seen LCM being applied very frequently when you're adding fractions. Okay, so when you're saying 1 by 3 plus 1 by 4, this is a common application. So all of you, again, this is a high school concept, so I won't go into the depth. You just calculate the LCM of 3 and 4, and then you multiply it, the entire sum by that value of 12, and then you will get 7 by 12. Okay, so this is one application. The other application is in terms of solving remainders types of questions. Okay, so typically in CAT, these kind of questions have been asked where you are given a remainder on division by a certain number of divisors, and then you have to identify the divisor based on certain conditions. Okay, so let us look at this approach. So here we are using LCM concept for solving different types of questions. One question is where you have the same remainder after dividing by different divisors. Another one is where you're having different remainders, but the difference between the divisor and the remainder is constant. Okay, next one is there's no pattern in any remainders, and the fourth one is you are using the remainders to identify the largest or smallest n digit numbers. So we will look at these four different types of questions, okay, and see how we can use the concepts of LCM to solve them. So the first one is the same remainder. So here what we are saying is, if I divide a number by 3, 4 and 5, it leaves a constant remainder of 2 in each case. So the first type is same remainder. Okay, whatever divisors, same remainder. So this kind of questions can be solved by finding LCM of 3, 4 and 5 and adding the remainder to that. Okay, so the LCM of 3, 4 and 5 is nothing but 60, and add a remainder of 2, so we get 62. Okay, so let's see another example. So here also we are saying a number is divided by 4, 6 and 7 and leaves the same remainder of 3 in each case. So this is the first type of question. Different divisors, same remainder. So just take LCM of 4, 6 and 7 and add 3 to it. So the LCM of 4, 6 and 7 is 84, and then I add a remainder of 3 to that. So I get 87. Okay. Now let's look at the next type of questions. They leave different remainders, but the difference between the divisor and the remainder is constant. Okay, so let us look at this question. A number on division by 5 leaves a remainder of 3, and on division by 7 leaves a remainder of 5. Find the smallest such number. So here we are observing that the difference between the divisor, which is 5, and the remainder, which is 3, is 2. Similarly, the difference between 7 and 5 is 2. So different remainders of 3 and 5, but the difference is constant value of 2. Now let us see how we typically solve these kind of questions. So let's assume n is equal to 5q plus 3 and also n is equal to 7r plus 5. Okay. Now 5q plus 3 can be written as 5q plus 5 minus 2, which is 5 into q plus 1 minus 2, or 7r plus 5 can be written as 7 into r plus 1 minus 2. Now both of them are equal to n, so we equate them. Okay, so we will get 5 into q plus 1 is equal to r into 7 plus 1. Okay, now 5 and 7 are co-prime, so q plus 1 should be 7 or a multiple of 7. So taking q plus 1 is equal to 7, we get q is equal to 6, or when I substitute q is equal to 6 into 5q plus 3, I will get n is equal to 33. Okay, so n is equal to 33 is the smallest such number. But how do we apply LCM concept to arrive at this particular type of questions, solve this kind of questions? So we do basically LCM of 5 and 7 and subtract the difference, which is 2. Okay, so to solve this, where the difference is constant, just take LCM of 5 and 7 and subtract it from the LCM. So let us solve one more question. So a number on division by 8 leaves a remainder of 4, and on division by 7 leaves a remainder of 3. Find the smallest such number. So here we are observing that the difference is 8 minus 4 is 4, and also 7 minus 3 is 4. So what do we need to do? Take LCM of 8 and 7, which are the divisors, and subtract 4 from it. Okay, so LCM of 8 and 7 is 56, and subtract 4, we'll get 52. Okay, so let's move on to the next type, where there's no pattern of remainders. So here we observe that a number on division by 11 leaves a remainder of 7, and on division by 6 leaves a remainder of 4. What is the smallest such number which meets these conditions? So let the number be n. N is equal to 11q plus 7 and also n is equal to 6r plus 4. So on equating them, we will get 11q plus 7 is equal to 6r plus 4 or 11q plus 3 is equal to 6r. Now 11q plus 3 is a multiple of 6. Okay, so we need to take a different possible values of q such that 11q plus 3 is a multiple of 6. So we'll get q is equal to, we can try 1, 2, 3 and so on. So we'll get q is equal to 3 or 36, which is divisible by 6. So substituting the value of 3, we will get 11 into 3 plus 7 is nothing but 40. So 40 is the smallest such number which satisfies this particular condition. So note here that there is no pattern in the remainders or the difference in remainders, difference between the divisor and the remainder. Next, the next type of questions that we get is related to identifying the largest or smallest n-digit numbers. Okay, so here what we do is we are asked a question of find the smallest 3-digit number which on division by 4 and 7 leaves a remainder of 3. Okay, so till now we saw that this falls into the first type of questions where the remainder is constant. So what will be the smallest such number, which is nothing but LCM of 4 and 7 with added with 3. So 28 plus 3 is 31. But we are not looking for the smallest number, we are looking for the smallest 3-digit number. So the smallest 3-digit number will be nothing but the LCM of 4 and 7 added with 3. Okay, so multiple of 28 which is greater than 100, which is the smallest 3-digit number, and add 3 to that. So the LCM of 4 and 7 is 28. The smallest number which is divisible by 28 and which is greater than 100 is 112. Okay, and we add 3 to that, so we get 115. Okay, so this is basically an extension of the concept method 1 which we applied before. So we are saying we need to identify the LCM and find that which is number which is divisible greater than 100 and then add 3 to that. Next is find the smallest 3-digit number which on division by 4 leaves a remainder of 2 and on division by 7 leaves a remainder of 5. So this is a second type of questions where the difference between the divisor and remainder is constant, which is 2. Okay, so 4 minus 2 is 2 and 7 minus 5 is 2. So basically we can identify the smallest number as LCM of 7 and 4, which is 28, minus 2, which is 26. But we are looking at the smallest 3-digit number. So what we have to do is find the smallest 3-digit number which is divisible by 28 and subtract 2 from that. Okay, so the smallest multiple of 28 greater than 100 is 112, as we saw in the previous question. So subtracting 2 from that, we get 110. Now let us look at another type of question. So here, this is the type 3 of question where there is no pattern. Here also we're trying to find the smallest 4-digit number. Okay, so just as we did before, we equate it for 7q plus 4 is equal to 4r plus 2, and we keep substituting the values of q where we get a multiple of 4. So we get q is equal to 2. So the smallest number possible is 18, and all the others numbers will be in the form of LCM of 4 and 7 plus 18. Okay, so all we need to do is find out any number which fits the pattern of 28k plus 18 such that it is greater than 1000. So you will get a k is equal to 36 and the answer is 1026. Okay, so this is how you apply the LCM concepts for the type 1, type 2 and type 3 questions, and type 1, type 2 and type 3 questions, and then you can apply this concept to any type of question whether you've been asked for 3-digit, 4-digit or any number of digit related for this type of questions, okay. So please revise these concepts again. This is a very important topic, and several questions have been asked in CAT on this particular topic. So you can find some of these questions in our mock test on our Android app as well. So you can revise the concepts and take the mock test called LCM in our mobile app. Thank you.